We can see it.
Recording started. So
All right.
welcome everybody to the technical steering. This time we are talking about Observability 2.0. So the stage is yours.
Okay. Thanks, Vedran. So why we actually are thinking about this topic, it has been quite a long time where some of the ideas that we have around solving current issues in the Gartner observability stack has been in discussions, and slowly some ideas are actually surface around these discussions. And now I will try to actually represent a consolidated view and result it in from all these discussions and ideas that we have. So that's the goal. Now I'll start with, of course, where we are coming from or where we started from. So in Gartner, observability, of course, has been present as a topic from its inceptions. So a lot of effort has been spent through the years, and the current observability concepts and implementations and tools that we use today actually are doing a good job. Because it has been proven that it suffices the operating activities or operation activities around Gartner. But we slowly started to observe some of the shortcomings, and we particularly around some tools that we use, about this highly opinionated stack that we use currently in the Gartner ecosystem. And it's become more and more apparent that we need a way to actually come up with a plan that would allow us to move forward and to provide a bit more freedom in how these toolings or tool set or practices can be introduced in the Gartner ecosystems in a more transparent and open manner. So we allowed various implementations and approaches around the whole topics of observability. So if you start with observability 1.0, and for example, the logging stack, maybe because there the problems are more obvious in the current implementations that we have or designs that we have. So in the logging area, we use a rather old tool called Valley, which is a open source fork of the latest Woki release with Apache license. And it has been a couple of years now that Valley is already in place, but itself, it doesn't move forward. So in order to get the latest, for example, tooling around logging carriers, this is not a tool that can be used. And it's not only the tool, but also the way that is currently used in the Gartner ecosystem. And I can very quickly demonstrate this problem by just opening one of the tools that we have. So this is a local development scenario that we have today. And this is the Prometheus, and I want to open the Plutonio. And then this is, of course, the visualizations around logs, for example, and just open arbitrary log view. So it doesn't really matter. But for example, all the data around logging in Gartner ecosystem, although following some best practices, it still reveals immediately a highly opinionated view of the metadata associated with logs. And logs, in order to facilitate all the debugging and supporting activities, it needs to be very easy to find them, isolate them, aggregate them, and come up with a different viewer representation. Hence, all the metadata around logging needs to be consistent. And for example, the tools or the metadata that we use today around logging is it is not at all consistent with what is commonly available in the community and open. For example, these fields that are seem so natural to us actually have a quite different representation depending on the tooling that you use. And I can imagine that any other gardener setup would probably reveal a bit different metadata or subset of data associated with the origin of the WOX as observability signals. And this is a big problem, not only because the practices in the community out there are different, but it also poses significant problems if we want to have these observability signals like logs externalized. So at the moment we get these data and push it to somewhere else, then we are pushing also our opinions on these metadata associated with logs, and that's a problem. Especially because you're actually telling other people how they can how they should organize their storing activities and aggregation activities around these observability signals. Not only that, but the current tool set that we use in Gardener actually does not provide any standard-based or open-based way or mechanism to get into these logs, simply because we have these very opinionated logging stack, and we have a concrete endpoints that we have, which reveals actually the dependency on the toolset behind. And if anybody wants to get into the details of these logs, then they need to wire themselves to these implementation details, and that's not something that we want to do, or at least it's something that we want to solve in the future. So this is one of the very immediate or obvious problems around the observability signals. Yes, we had some very good ideas in place, like having these functionality or capabilities of our log shippers in the Gardener ecosystem to produce different type of logs, for example. So it's not really mandatory to ship or provide the logs only in the Valley backends, but through using tools set like full-embed operators, we have a declarative and respective APIs. And CRDs, we have a declarative way to actually ship these logs in any other format which is supported by the full-embed. But yet it doesn't actually solve the problem on the consuming part. It solves a bit to the problem on the producing part. And nevertheless, it's still not a consistent way to solve or approach this kind of a problem. Going into monitoring area, for example, there these problems are not that apparent or visible because de facto Prometheus and the data format of Prometheus metrics de facto become a standard in Kubernetes ecosystem. So more or less there is nothing else out there which serves metrics as observability signals, and the whole tooling and ecosystem actually converge around these data formats, and that's still kind of hides this problem that we have a dominant format for expressing these metrics. Yet these problems around attaching metadata around these metrics is still not entirely solved because here, depending on the implementation of the exporters, if we say they can attach these label formats in a different way around the metrics, employing different naming strategies. And then again, these problems will become quite visible if for whatever reason some exporter in the metrics does not use namespace as such, or use rather different type of a label name to express the same semantic, and then we have or end up in the same set of problems. So if we go into summarize the problems around the current observability stacks or paradigms, it is apparently visible that we still treat these observability signals like metrics and walks and traces, although we don't deal with traces in the Gardener ecosystem yet. We treat them rather separately. And not only that they belong separately from the how to say logical perspective or the information they outline, but we treat that separately also by how we name, for example, the origins or resources that produce these observability signals. So we treat them with naming conventions which are not consistent, not aligned together. And even when you look into metrics and walks into the UIs that we use today, actually it requires a bit of translation effort to distinguish or to align these signals to the same place where they originated from. So the question is how we can actually solve these problems, how we can actually allow a less opinionated stack, and how we can offer different architectural patterns and implementations in the Gardener ecosystem. And the one reason actually to going there, it's actually always the question to this, or the answer to this question has been employing an open standards and community accepted or industry accepted practices and tools. And here comes the notion of observability 2.0 covered or enabled by using OpenTelemetry. So why we actually shifting between observability 1.0, the current practices, and why we introduce 2.0 as a concept is actually because we want to bring the notion of open standards into the whole ecosystem. So the way how we actually package these observability signals, how we then represent them, how we move from one place to another should be based on open standards. So avoiding these opinionated stacks as much as we can, and allow actually to have a pluggable kind of mechanism to choose between different vendors. And this as an activity has already been present and quite dominant in the observability ecosystem around Kubernetes toolset. So more and more vendors out there, they employ an open standard approach using OpenTelemetry as a data format, and not only data format, but it uses also as a transport protocol, or the specification around transporting these observability signals. So TLP is in place. And that allow us to actually walk into the picture from a two neutral point of view. So we can have a data model which brings together walks, metrics, and traces. Again, traces is just an example of yet another observability signal which is not yet present, at least in the Gardener ecosystem. But we can use these open standards for the format, and then we can also bring transport protocols, which are, again, vendor agnostic, so no walk-in into the way that you are moving these signals from place to place. And we also want to leverage these semantic conventions around how we are attaching metadata around this observability signal. So, for example, to have a common attributes or naming conventions about the names that we attach for example, like Kubernetes pod names or namespace names. So you can see there is quite a difference in how these attributes are called in this ecosystem. And the promise here is that if everybody is actually following these naming convention, it will become easier or more natural to work with those signals and to move them from place to place. So, for example, if we want to output or externalize these observability signals out there, it is quite better to say, hey, we are producing an open standards formatted observability signals using a vendor agnostic protocol for like OTLP. And then suddenly things are becoming much more natural and easy to move these data from place to place. And all these little new developments in the ecosystem actually can be seen even now, because we have seen that all the tool set out there, they're moving towards supporting OpenTelemetry in one way or another. Even Prometheus ecosystem, for example, they with the latest release of Prometheus, they provided OTLP ingestion endpoints, and now they can actually serve as a pure OpenTelemetry based storage for metrics. So it's not necessary any longer just to scrape metrics from Prometheus from the exporters, but metrics can be pushed to Prometheus and stored there. And then, of course, when the signals or the metrics are there, that we can use the same very well known and understood query language of Prometheus to actually look into these data. On the logging stack, there is a lot of developments around very prominent tools like OpenSearch. They also support OTLP. ClickHouse also supports OTLP. Actually, ClickHouse has they work for a couple of years now, and they offered themselves as a backend incorporating all of the three major types of observability signals. So currently, ClickHouse supports traces and logs and metrics in the same backend storage, which is quite interesting. But of course, ClickHouse is now SQL database offering, and then from that perspective, bring other challenges, particularly when we want to query or aggregate these data. VictoriaWorks is one prominent example where they also have an OTLP ingestion endpoint. So no matter how these observability signals are actually produced for Works, they can be stored in VictoriaWorks as a tool set. All these are open source, so it's only no commercial offering will be mentioned in this session. Only tools which have a pure open source licenses and are de facto used in the ecosystem. So VictoriaWorks is another prominent example. FluentBit as a log shipper implementation, they have been working for quite some time on producing part, both on FluentBit inputs and outputs endpoints of the log shipper to actually being able to consume OpenTelemetry signals and output OpenTelemetry signals. So there is also some work already present with with some experience behind it. So all these tooling actually matured quite a lot, and the whole ecosystem out there is looking into these offerings at the moment. And Observability 2.0 in Gartner ecosystem is dealing with the fact or the problem how we can have a mechanics or at least implementation and support for processing of OpenTelemetry in a way that does not provide any vendor lock-in type of architecture or implementation. And OpenTelemetry is such a tool. And for example, VictoriaWorks is, as I said, is an open source project, but it doesn't, at least for now, for at this moment, it is not part of any foundation or CNCF foundation, and as such, there is no a hard guarantee for these tools that they will remain under open source licensing. So it's up to the project owners and maintainers to decide how they want to evolve. But going into open telemetry as an open standards to some point relaxes these dependencies. So if one tools decide to go in a different way for whatever reason, simply employing the fact that you use an open standard model for these signals would eventually means that it will be relatively easy to bring another tools that supports these open standards. So from that perspective, it's kind of a bit more safe to go into the future because open standards guarantee that tools supporting these standards at least could be exchangeable easily. And now that being said, how actually we are looking into bringing open telemetry and observability into Gartner. It is not fundamentally different of what we have today, because even today we have this notion of utilizing operator concept for dealing with dependencies in the observability stack. So we have this Fluentbit operator, we have Prometheus operator, and the ecosystem out there, they already have an open telemetry operator, which deals around instantiating open telemetry collector distribution. So these are endpoints which are used or components which usually translate observability signals from one place to another. And they have the ability to provide a multiple receiving endpoints and exporting endpoints, and this actually receiving and exporting data formats within a different formats. And for us, bringing an open telemetry collector in the center of a shoot control plane actually makes quite a sense, because it will allow us to independently replace the log shippers or the backend storage independently. As long as we have the necessary exporter in place, then these functionalities will be very easily to allow different vendors to be put into this system or architecture. And we do have plans to actually replace our Valley with VictoriaWorks at some point in the future, independent from how we actually dealing with the Fluentbits which are running on the seeds. So at the end, if we have all signals produced and consumed in OTLP format, it will be defined, and the necessary steps meanwhile actually is not required to be tightly coupled together. So it will give us flexibility in slowly evolving different parts of the observability stacks whenever they're ready, or they consume, or they think it's time to switch from current proprietary formats into open telemetry, then they will be able to do so. And there will be an open telemetry collector which will be able to translate these signals if necessary from one side to another. So we want to bring the open telemetry collector as the first step, then still have produced our logging stacks with Fluentbit and Valley outputs that we use today, and still have the Valley as a backend storage, and then decide and look into how we can actually exchange and independently bump up or change these stacks here. So Valley will go off, and then VictoriaWorks will come up, and Fluentbit will start produce logs in OTLP format naturally, so without needed of any translation mechanism which is required today. And even today, as I said, the log shippers are they already able to produce these logs. So not only that, but we want to another log shipper that we have today is Valley tails, which are running on shoot nodes. And today we use the Valley tail output or component which actually fetches these walks and packages them into the Valley specific backend, and we want to replace this with OpenTelemetry collector and actually fetch these walks from the chutes and send them to an OTLP endpoint. So again, we can send them to the OpenTelemetry collector, and the OpenTelemetry collector can then, based on properties, decide where and how to move these signals forward. So it really becomes a central heart for delivering or navigation of these observability signals, and this comes naturally with its implementation. And if you look into the current abilities or what else is actually possible with OpenTelemetry collector, then activities like filtering and routing, which are very tedious now to be implemented because these are not very solve or easy to solve problems today. Because these activities have already a natural part in these OpenTelemetry collector implementations, these scenarios are becoming much more easy to implement. So how I route or how I filter or what exactly I'm producing or exposing outside from an OpenTelemetry collector becomes more naturally to be implemented. So I'm not going much into details, but this is something that we are looking for. So what else? So bringing first the OpenTelemetry operator, the same way we bring Fluent operator, Prometheus operator. De facto, it mirrors the current approaches. So nothing will be changed from that perspective. But then the question would be what an OpenTelemetry collector type of distribution we want to bring in. So just because we have different capabilities on receiving part and exporting part and different abilities on processing parts, so whether I filter, sample, route, or what exactly aggregation I do on these observability signals, these are properties are incarnated or represented in something which is called OpenTelemetry collector distribution. There is a core distribution which supports only OTLP. There is a contribution distribution which supports any major vendor inputs and outputs. There is a Kubernetes distribution which is somewhere in between those two. But we already experimented and come up with a very fine-tuned Gardener type of OpenTelemetry collector distribution, which in addition to Prometheus and OTLP support, it supports also Valley as a receiver and exporter, plus the needed filtering, routing, and attribute manipulation processing components there. Actually, this is an example of pipeline. I think we have, maybe I can show this very easily. Let me see. This is the distribution. And if you input and you quickly browse through what would be the proposed exporter, processors, receivers, and extensions that can be easily seen. And from receiving part, let's say into the receivers, OTLP definitely will be supported. File logging receiver or file walk receiver will be supported. This is de facto mirrors the Fluentbit or Walkshipper capabilities. Journal Ds required because we want to fetch the walks from system D units, which are running on chutes. We can eventually look into replacing our current event logger component that we use today to walk the events from Kube API server, so that naturally can go away, and then we can use the receiver parts in our distribution, and so on and so on. So I'm not going to each component here, but definitely the accepted practice in the industry is that OpenTelemetry collector distributions are easy to be built, and they should be tailored for the specific of each environment. So here is one proposal how that can look into the Gartner ecosystems, and of
Nikki,
course, yeah.
I don't mean to interrupt you, but we already spent 30 minutes for the proposal presentation. We should come to an end so that we can start a discussion.
All right. Good. So this is as I said, this is the proposal. This can evolve in the future with different capabilities needs. This is an example of an OpenTelemetry collector resource definition, defining a typical pipeline that is used by these collectors. So I'm not going to spend much into the full Mbit migration, how we want to utilize the same semantic conventions. Maybe the one thing that needs to be said is actually OpenTelemetry will give us the answer to how we want to move or supply observability signals from Gartner into some external consumer system by using an open standards. And here it is the combination of the natural extension mechanism in Gartner by providing extension components for the shoots. And such additional collector can be used or specified by the shoot owner, so they can, for example, specify a concrete OTOP endpoint with the necessary credential on their perspective, and then we can push some of the observability signals from the shoot control planes through these components into whatever a shoot owner wants to have in a vendor agnostic and open standard based data format. And I think this is a good opportunity for us to solve this problem in a standard way, utilizing open standards. More or less, I will stop here. All these components or points have been put here in this document, and of course, those are public, so I guess they can be seen. And now we can start the discussion.
Thanks for the presentation and the well-written proposal. I think it outlined the most important points pretty well. So as a general feeling from my side, I think this is the right direction to go. As said, motivation is pretty clear, at least to me. Also, one point that was not mentioned, but would also be a plus point for the proposal is that when today you want to forward metrics and logs to a central place like we do, you have to fiddle around with different mechanisms and so on. And this would be unified with the new approach of Observability 2.0. This would very much push this forward. And in another round, we also discussed this approach and how different Gartner operators could make use of it. And I think building this Observability 2.0 as a base would allow, developing such a generic observability extension that would fit the needs of different companies and so on. So I think this is the right way to go. I still think that the migration plan, although it is outlined in this document in a high level, should be detailed better, probably in a form of a Gartner enhancement proposal, where we can take a look at the very specific steps of rolling things out and how extensions need to be adapted and so on and so forth. So that we don't stumble on our feet then. Yeah, that was just a starting feedback.
Yeah, maybe a general question how this would look like in the end, because I'm not so deep into this open telemetry and everything. So eventually there is something, this OTel collector is a deployment on the suite control plane. Is this correct? First of all?
Open telemetry collector is a deployment in the shoot control plane, yes.
Okay. And this is the point from where the observability signals will be pushed to wherever. For example, Victoria Logs or some external remote endpoint.
I'm sorry, I didn't hear you well.
I was saying that this open telemetry collector is the place basically which pushes them to some backend, for example, the Victoria Logs or some remote backend, whatever. Okay.
Exactly. They have this notion of exporters, and basically right now, if you look into what is currently supported, if you go into the OpenTelemetry contrib package, and here in the exporter parts, then you see any major vendor writing an exporter package so they can push these observability signals to their backends. And they, of course, as you can see, so Cassandra, ClickHouse as a backends, and they actually have to say to what type of signal they support, but this is an implementation details. But here, around the what is available, at least in our site, we want to get rid of Valley and bring Victoria Logs here. But if the ecosystem decides that they wanted something else, then it will be easily exchangeable.
But for now, we would keep the Prometheus per shoot control plane as a metric store, right? So we would only extract the, let's say, the transport and collection mechanism, right?
Yes.
Okay.
No need, with this approach, there is no need for big bang change. So all these different components, they can migrate whenever they decide it's time to do so.
What do you mean, Tim, with that? We will only exchange the export part. What does it mean exactly?
So right now, the Prometheus is responsible for scraping the components and also storing it for later retrieval, right? And this would be basically split into two components. The open telemetry collector would probably in the first step scrape the components just like Prometheus would do, collect them and send them to the Prometheus for storage.
Okay, so Prometheus will not scrape directly anymore.
There is no hard requirement to do so immediately. That's to be clear. So bringing all these collectors into the current ecosystem does not bring a requirement for changing other parts. They can still continue work and save as they do today. And whenever we decide it's time to move, then we can switch. So that's very important to be said.
But just to understand, what is our goal? I mean, right, we have moved basically. Just give me a second. We have basically moved to Prometheus operator, moved all the scrape configs and that kind of stuff. Will we then move that over to OTel collector completely, or is that basically something that we kind of keep because we assume that Prometheus will still be kind of our metric store?
We can keep it as it is today. And we can remove if we decide to move away from that and doing the open telemetry collector to scrape these endpoints and then push to Prometheus, we can do so. We'll have the mechanism. It's not a requirement to do this immediately at the end. To me, my final picture would be that all the signals will be scraped from open telemetry collector in the format and represented as OTel data. And with OpenTelemetry collector, we can do this, but it's not a requirement to start immediately, like a big bang change, and then move everything there.
No, I was not asking about a big bang change. I was just asking whether we actually want to do it. Is that part of what we want to achieve, or is that just an option we will decide later on?
It's an option we'll decide later on.
Okay.
I have another detailed question about logs collection on the seed. So in the proposal, it still talks about FluentBit and the custom output plugin. So without knowing much details about the OpenTelemetry collector, I assume that it could also collect logs from Kubernetes nodes, enrich them with metadata and so on. So I was wondering whether a general OpenTelemetry collector deployment, or rather daemon set on the seed, could also fit the purpose of collecting the seed nodes and transporting it to the different shoot-specific collectors, or the seed-specific value, or whatever that might be then in the end.
The problem it's not that needs to be solved is the dynamic notion of the targets related to the shoot control plane. So if we have instances as of today that we have Valley and Victoria Walks instances which come and go because shoots are created or deleted, and then you need this flexibility to be reflected in the output plugins on the FluentBit. So and that's why we have this plugin even today. If we have a single central place where we ship everything to it, then of course, these plugins are not needed to be there. But this is easily solvable even today, because today we just deploy a FluentBit output definition with this target, and then you don't need to deal with this dynamic feature. But if you want to reflect that at any given time shoots can come and go with their own instances of the logs backend storage, that then you need to be a bit more flexible into defining these outputs into the FluentBit. And FluentBit architecture already provided quite a good API for this implementation, so we use them already. But it is more or less solving this fact that each shoot has its own working backend storage, which can go and come very easily. But
I would assume that if you replace the FluentBit with another OpenTelemetry collector, it could also be configured dynamically, probably with the corresponding operator, to have a dynamic target of shoot-specific OpenTelemetry collectors, which would then store the data in the respective store. Right.
Yeah, in theory, absolutely, yes. In theory, that's also possible. Of course, the details are, devils are in details, and we need to have a proven reliability way to actually do this. But yeah, your way of thinking is correct.
Okay, because I would like to see that then, if that's possible, because using OpenTelemetry for this aspect as well would allow us to get rid of one more component and different or custom mechanism, and in favor of one general solution, which is kind of the point of your proposal, right?
Absolutely, yeah.
Okay.
But I would not go without a solid proof that actually is working reliably. I mean, we are running tens of thousands of clusters, and logs are critical for operations. And without a solid proof that everything is stable. But you're correct.
And can you say something about, when I read a bit up front, I understood that there are sidecar containers for OpenTelemetry. Can you explain a bit about that?
Sidecar containers for OpenTelemetry.
Yes, sidecar containers that somehow expose the whatever metrics or traces in a format that can then be shipped to this collector. Is this something that we will use in our scenario? Is this not planned this way?
No. Sidecars, at least in our case,
You're talking about the instrumentation, right? OpenTelemetry has this notion of injecting sidecars for collecting observability signals like logs or via some wild eBPF components or whatever. I don't know.
Okay.
Yeah.
Okay, good. Now, yes, this is the approach for auto instrumentation. Actually, in Golang, there is, as you know, there is no auto instrumentation as Java or source code gimmicks and Python as Python, which would allow us this code to emit observability signals or OpenTelemetry signals. But there are two very, how to say, prominent efforts as of today in the Golang ecosystem. One is to actually using eBPF. So you are not changing your binary, but you are plugging this eBPF execution hooks, which are observing the execution flows, and then through them they can emit observability signals. So it's kind of a auto instrumentation, but it's not the correct term because you're not instrumenting the code that is running, right? So you are providing a hook around execution of this code, which can emit the observability signal. So this is the one current proposal. The second one is more interesting to me because there is some standardization effort today. I think that there are links in this document towards providing a compile time instrumentation, which basically would go scan the code and detect if particular libraries like standard net HTTP package is used or gRPC is used, or all these communication components or protocol implementations like database connections or whatever are used in a Go source, then a specific points will be enhanced and the source will be actually plumbed before the compile time. So this is actually a modification of the source code, which will, although you are not implementing it concretely, so you're not coding it particularly, then with the help of this tooling, the necessary code will be plumbed into, and then the binary will be compiled with the ability to emit these components. And the good thing is that they want to make it standard. So how this will look like, I don't know. It's not a final thing at the moment, but the working group is already established, and I have seen some good progress around it. And those two mechanisms, which actually would not require any type of this sidecar instrumentation or addition that you, Raphael, is pointing to. So we are not going to use it, and we are not going to need it. Yeah. Especially these two areas produced a reliable and good way to instrument Go applications.
Can I play devil's advocate for a minute, just to understand how you see that? If I just look at the pain point list that you have here for Observability 1.0, I could argue at least some of them we could do completely without OpenTelemetry. For example, the standardization on the attributes, that's more or less something we could do today. It might be quite some effort. It's just we have to go all over the place and kind of use the standard ways to do it. Then one thing we seem to address here more or less indirectly is getting rid of our kind of legacy components, Plutono Vali, where we don't really have a sustainable solution. And frankly, I mean, we could do that also without OpenTelemetry. I think with the way described here, it seems like a kind of a way without a lot of disruption, which is good. But we could potentially also do that without. Now, I see that the feature that you highlighted for exporting the observability data, that's certainly something, if you don't want to go the kind of specific bound to opinionated way, bound to certain tools, there OpenTelemetry is certainly helpful. But I mean, frankly, we are in the Gartner ecosystem. We are opinionated in several ways. So arguing, well, our opinionated solution is X, might also be something. So I like the proposal. Just would like to understand from your point of view, is the export via OpenTelemetry the most important thing, or maybe I don't see the priority there that you see, or did I miss something here?
Yeah, good question. In my opinion, if we want to establish Gartner as a foundation of in a broader round around independent European ecosystem of provisioning, computes and those efforts for EU sovereign cloud infrastructure and offering then citing and relying on open standards actually is a strong message. So yes, we can solve all these problems without actually going into this direction. But I think that if we want to establish Gartner as de facto a standard offering, then utilization of these kind of standards is actually an important wording or part of the whole story. So that's my how to say motivator for going into this direction.
I wouldn't say that what we use today doesn't use open standards. Like Prometheus format for metrics is also an open standard, right? I think the main benefit of going for OpenTelemetry is that it is uniform for all the observability signals, and it basically sets us up for leveraging more work that the community does in the future. I could imagine, for example, that once we start deploying an OpenTelemetry collector to the shoot nodes for collecting the system logs, we could also offer this as a feature to Gartner end users, where we also collect logs of the workload components and so on, or even the metrics. So I think this offers new possibilities by using the tools from the community. But for solving the immediate challenges that you listed, Johannes, we wouldn't need it. That's true.
To me, there is a difference between strategic thinking and these concrete use cases. So going into this OpenTelemetry and open standards more on the strategic path of Gartner evolution. So we have to think like 2 years, 3 years from now. And I think this is the main message.
Sure, makes absolutely sense. I just wanted to see also your point of view there. Okay. Just going a step further, as basically, Tim, you also just noted we could then collect potentially also even more. I mean, right now, stakeholders or cluster owners who want to have their logs usually have their own logging infrastructures or logging stacks, and they collect their logs somewhere. And meaning, if they also want to collect the system logs, for example, they have to set up similar stuff that we do with Valitail, for example, on the nodes, and push it to their backends. Now, if we use OpenTelemetry, we could offer them, as you said here, a service, but would we end up then in a probably not perfect situation that the OpenTelemetry collector is running on our control plane as depicted here, collecting the logs from the shoot nodes, and then sending the logs again to the shoot nodes.
Yeah.
Which is kind of depending on the infrastructure, depending on the setup between control plane and data plane, might be internet traffic in multiple directions.
Yeah, you're absolutely right. I would say let's not start with that concrete problem to solve, because it's not really so critical, at least for now. And maybe we would, if we decide to go that way, at least we'll have the technical components that can do so. Maybe to me, moving these walkthrough over the internet and generating cost doesn't make much sense. Much more sense makes it to offer a pluggable way for the shoot owners to actually fetch these signals on the place of origin, and not to move this amount of traffic from all over the internet from one place to another, just to end again into some external system. But yeah, I would say at least for time being, or at least for in the beginning, this will not be the case. So we will not generate a system walks from the local shoot node moving to the seed, and then export from the seed to the shoot benefit. We'll move this only for our operational needs, at least in the beginning. And then these services, they can evolve in the future. I guess, we'll have a stronger opinion back after operating this architecture for some time. And then we'll have a better sound answer to these kind of questions, whether and how exactly I can fetch system walks from the shoot nodes.
Yeah, I completely agreed. I think I just wanted to raise the potential downside, just potential, that if we offer a standardized, easy-to-use solution, you can also very easy build something on top of that. Like, for example, you can take the logs back from the control plane to the data plane, and you will not see it directly. I mean, unless you really take a closer look at your costs, and internet costs are really tricky, then people might be able to build stupid solutions. I mean, they might be able to build that anyway. So, yeah.
But if I understood correctly, what is depicted in this architecture is that these are basically separate OpenTelemetry collectors, right? So one would run in the shoot control plane and one in the data plane. And the benefit of this is that you once you start offering that customers can configure these, they could push the signals directly from where they are collected to the target observability stack, right? Without going through VPN or back and forth and this internet traffic that you mentioned, Johannes.
Yeah,
yes,
technically it's possible.
I think that if we do it like that, that's perfect, right? So the question is just, I mean, if we collect the data anyway into our shoot control plane and then we push from there, then we would, then that would not be the perfect solution. If we can basically tell the OpenTelemetry collector on the nodes to have potentially two endpoints, because we want to have our for operations reason for our components, we want to have the logs, but they should also go somewhere else. That would be perfect. I'm not sure, but I mean, we can see how that pans out. Yeah.
So now that the hour is over, we should reach a conclusion here, right? Formalize a decision.
I still have time if we need to continue, so no problems on my side.
Yeah, so my understanding is process-wise, we have understood basically the proposal, or at least unless there are further questions. I mean, I can only speak for myself. I think I have understood it. I think the next step would be to have a separate call with sponsors, basically management or companies that would sponsor such a proposal. I see one sponsor on the call, which might be also in the follow-up call.
But this is for the product steering, right?
Isn't this a product steering?
Looking at the meeting title, it says technical steering.
Then I'm lost. Sorry. Forget everything what I have said. Back to you, Tim.
But I mean, this is the first time we have this technical steering, right? So we can still figure out the process, yes. But for now we have documented that the decision should be taken in the same meeting.
Yes.
Right.
So let's say the decision could be to say OpenTelemetry, the proposal is good, and we want to implement it. And another decision could be the decision is not so, the proposal is not so good, we don't want to take it. That's two easy decisions. I don't know. Do we see something else to in between, or?
Not really.
I don't think so.
Yeah, I think we are right now establishing the process, as Tim also said, and the decision that we need to do something, I think that is more or less that happened already in the past. So now the question is only how to go about it. And indeed, I have no clue how to make the decision right now. So I have talked to Niki a couple of months back. So therefore, for me, that's a go. But now we are more people in this call, so practicing it.
Yeah, speaking for myself, my vote would also be to go for this direction, with the remark that the details should be outlined in a full GEP, probably, at least for the changes that affect Gardener and the extensions and so on. If we do it like this, I think this is the right way to go.
Okay, fully agreed.
There will be a couple of gaps because one, I can see easily at least three, because one will be the operator, so similarly to GEP 19. Second will be the current presence and architectural description of the deployment of the OpenTelemetry collector featuring the Gardener distribution. So this is a new GEP that will be describing the exact role from architectural perspective of the presence of OpenTelemetry collector in the should control planes. And the third GEP in the future will be describing the OpenTelemetry collector Gardener extension. So at least three gaps I see in this proposal, and I think we can start with the first two. And once we migrate internally the observability stack towards OpenTelemetry, and then we can focus also on the third gap, which is externalizing the data outside. And I think this, at least in my view, these are the gaps that will come. So at least three documents, in my opinion.
Okay, good.
But if you say we need something else, that's also fine. I mean,
no, that sounds good. That's exactly, you are basically answering the question before I could ask it, because I was just wondering what do we just want to have one gap and kind of highlight everything, which will be quite big, or whether we go in smaller increments, because you already highlighted, for example, things like do we want to change Prometheus, everything? We don't need to you proposed now to go in smaller steps to basically have one part. We do one gap for that. We have another part. We do a gap for that. That's completely fine. So sounds good to me.
Okay.
I think this is all we can decide on right now, right? So once we have the more detailed proposals for the individual steps, then folks will align on it. Probably also doesn't have to be this round, rather the Gardner maintainers or whoever wants to contribute there. But for now, we can decide on the general direction which was presented. So this is good for me.
All right, then thank you very much, Nikki, for the presentation, everybody for the active contributions. I will write down the meeting minutes, publish them, and Raphael will upload the video. Thank you very much, everybody.
Thank you.
Thank you.
Bye.
Thanks.
Bye.
Bye.